Yes, students, we have been discussing about logarithms, how to find the logarithm of any given number and what for it is used, and here it is how to make use of logarithm table. In last class only, it has been shown to you how actually scientific data book will be there, and that scientific data book, which is known as a Clark's table, by using which I told you we can find the Mantissa part. And before that, what we have seen in last class, to find the logarithmic value of any given number, actually we need two parts there. One is its characteristic, and the next is Mantissa part. Logarithm of any given number consisting of two parts. While finding the logarithmic value of any given number, we should find its two parts, characteristic part and Mantissa part. And how can we find the characteristic part while finding the logarithmic value of any given number? That I already did discuss in the last class. That characteristic of any given number can be found just by the method of by following the method of inspection. If you see at the given number of which logarithmic value should be found, then if you know the place to where that given number of which logarithmic value is to be found, whether does it belong to 10th place or 100th place or 1000th place, depending upon that we can find its characteristic. If the given number is in a 1000th place, then its characteristic will be 3. If the given number is in 100th place, its characteristic will be 2. By following the two rules there, it was discussed in the last class how easily we can find the characteristic part. Actually, let me remember those two rules which are there to find the characteristic of any given number while finding the logarithmic value of that given number. That is, characteristic is equal to n minus 1 and characteristic is equal to minus of n plus 1. Two rules are there which we can make use while finding the characteristic part of any given number while finding its logarithmic value. Characteristic is equal to n minus 1 rule, that is there if the given number of which logarithmic value is to be found, if it is greater than 1. And one more rule is there, minus of n plus 1. That rule we have to make use while finding the characteristic of any given number if that number is less than 1. Okay, here now together both characteristic part and Mantissa part, how can we find? Characteristic part should be found by following the method of inspection, and to find the Mantissa part, I told you we require Clark's table or scientific data book. I have given a long gap in between my last class and this class, so that you can buy this Clark's table. Now I think all of you could have bought this Clark's table. Still, if you have not bought this Clark's table or scientific data book, please buy it as early as possible, because which will help us to find the Mantissa. Without this Clark's table, we are not able to find the Mantissa part. I have taken one example here. If suppose if I want to find the logarithmic value of this 1897, while finding the logarithmic value of this one number, first thing what we have to do, we have to make that given number of 4 digits. That given number should be made of 4 digits. Of course, here for example what I took, that itself is of 4 digits, 1897. Still I write like this, 1897.00. Like this, whatever the given number, that should be made of 4 digits. Suppose if I have been asked to find the logarithmic value of 18, then also have to make this 18 of 4 digits. How can that be done? I tell you in the next example. First, let me find out logarithmic value of this number, 1897.00. Look at this number, 1897. While finding logarithmic value of this number, first we have to find the characteristic of this number. And to find the characteristic part, first it has to be seen that number of which logarithmic value is to be found, whether is that greater than 1 or less than 1. 1897 is greater than 1, no doubt in that, is greater than 1. If the given number is greater than 1, then characteristic of that number is equal to n minus 1. We are supposed to follow this rule to find its characteristic. That is, characteristic Ch is equal to n minus 1 rule, because 1897 is greater than 1. Okay, what is n there? N is number of digits before decimal point. That's why I have written 1897 as a 1897.00. Here there is a decimal point. Now, before this decimal point, how many digits are there? 4 digits. 1, 2, 3, 4. 4 digits are there. For this example, our n becomes 4. 4 minus 1, 3. Now, the characteristic of this number is 3. Now, characteristic of this number is found. Let us find out Mantissa part of this. Again, I am telling that to find the Mantissa part of a given number while finding its logarithmic value, we have to make use of a class table or logarithmic table or scientific data book like this. Turn over the pages in this book. In page number 2 and 3, we will have some rows and columns there. In page number 2 and 3, actually at the extreme left column of this logarithmic table, the numbers are started from 10, 11, 12, 13, 14, 15 like this up to 54, and the same is continued in the next page, that is from 55 to 99. Overall, in this logarithmic table, its extreme left column is started from 10 and ended with the 99. That only I have shown here on the board. The left column, left column is started from 10 and ended with the 99. Next, horizontal top row. In this table, horizontal top row is started from 0. This horizontal top row is started from 0 and ended with the 9. And after that 9, one more table is there. One more table. That column or that table is called as a mean difference column. And that mean difference column is also started from 1 and ended with the 9. Here there is mean difference column is started from a 1 and ended with the 9. Overall, the table is consisting of columns and rows. This is a horizontal top row, top row, and this is left column. It is started from 10 and ended with 99. Top row is started from 0 and ended with 9. One more column is there, that is a mean difference column, which also is started from 1 and ended with 9. Okay. Now to find the Mantissa part of this example 1897, already characteristic part is found by following the rule Ch is equal to n minus 1. Why did I make use of n minus 1 rule here? Because 1897 is greater than 1. If the given number of which logarithmic value should be found, if it is greater than 1, we are supposed to make use of this rule that already we discussed in the last class. Okay, characteristic is 3. Now the Mantissa part. While finding the Mantissa of this, what is to be made of this given number? First two non-zero digits of this 1897, first two non-zero digits. Which are non-zero digits here? 1 and 8. Together it is 18. First two non-zero digits have to be located in a left column in this table. First two non-zero digits. First two non-zero digits have to be located, have to be seen in the left column. First two non-zero digits. Here first two non-zero digits means 18. These two non-zero digits have to be located in the left column. Third digit should be seen in horizontal top row. What is the third digit here? 9. 9 is the third digit. First two non-zero digits are 18. First two non-zero digits. Non-zero digits. Those have to be located in left column. Third digit. What is third digit in this example? 9 is the third digit. This third digit should be located in the top row. Third digit should be seen in top row. It means 18 I have to see here in this left column, which is started from a 10, 11, 12, 13, 14, 15, 16, 17, 18, somewhere here. 18, third digit. What is the third digit? 9. Where it should be seen? It should be seen in the top row. In this column, 18. And horizontal top row, third digit, 9. Under 9. In this 18 row, 9th column. Under this 18th row, by following in left column, 9th row, 9th column, 18th row, I get some number here. Here it is, look at this. First two non-zero digits, 18 should be seen in left column. Under this 9th, 18 under 9, whatever the value we will be getting there, 18 under 9, we will be getting this value there. What's that? 2765. 2765. Here, this value I am getting 2765. Whatever the value I get inside the table, in logarithm table, that should be taken along with the decimal point. That is along with the decimal point. When it is seen 18 under 9, this value I am getting there in the table, in Clark's table or logarithm table. 18 under 9, that is 0.2765. Okay, up to third digit it's over. Now fourth digit is also existing there. Fourth digit is 7. 7 is the fourth digit. If there is a fourth digit, then that fourth digit should be seen in mean difference column. Fourth digit in mean difference column. It means in this example, fourth digit is 7. In the same row, 18, in mean difference column 7, the value, whatever the value is there, that should be taken. In this logarithmic table, 18 under 9, 0.2765, that value. In the same row, under 7, the value is 16. In mean difference column, 18 under 7, the value is 16. This is 16 in mean difference column, whatever we are getting 18 under 7, that should be added with this 0.2765 plus 16, that is 0.2781. 0.2765 plus 16, the value 18 under 7 in mean difference column. The total will be on adding that mean difference value with this value in the table. This is 0.2781. This is the Mantissa part. Now, logarithmic value of 1897 is equal to 3.2781. This is how we can find the logarithmic value of any given number. First, what we have to make that? We have to make that given number so that it should be of 4 digits. If it is of 5 digits, then make that fifth digit, round it off to the 4 digits. If it is of less than 4 digits, if it is a short falling, then take some zeros, make it as a 4 digits, on adding some required number of zeros, so that it can be of 4 digits. If it is more than 4 digits, that given number of which logarithmic value is to be found, then you round it off to the 4th digit. Okay, now logarithmic value of 1897 to the base 10 is equal to 3.2781. Here 3 is characteristic, 0.2781 is a Mantissa. Or even you can understand this 3 is the integral part and 0.2781 is a decimal part. In other words, how can we understand this? In other words, we can understand like this. Whenever I multiply this 10 these many times, 3.2781 times, then I am going to get this value. Which value? 1897. When I multiply 10 these many times, I can get 1897. I already told you in logarithm what we do there. We try to express that given number in terms of power of 10. What we do there? Given in logarithms, we try to express that in common logarithm, especially there are 2 types, common logarithm and Napier's logarithm. Common logarithm and natural logarithm. In common logarithm, we are taking the base as a 10, fixed number as a 10, and we are expressing that given number in terms of power of 10. Whenever you multiply 10 these many times, 10, when you multiply 10 2 times, 10 into 10, you will get 100. That's why 100 can be written as a 100 is equal to 10 to the power of 2. When you multiply 10 3 times, we are going to get 1000. 1000 is equal to 10 to the power of 3. Similarly, when you multiply 10 these many times, 3.278 one times, then we will get 1897. This is how you can find the logarithmic value of any given number. Now, of this second example, let us see. Of this second example, logarithm of 18. If you want to find logarithmic value of this 18 to the base 10, first what we have to make? We have to find its characteristic or integral part. How to find its characteristic? There is a rule. Characteristic is equal to n minus 1. Why that n minus 1 rule is to be followed? Because 18 is greater than 1. If the given number, if it is greater than 1, given number is greater than 1 or equal to 1, then of such number, characteristic can be found by following this rule, n minus 1 rule. Now 18, I make it 18 as a 18.00. See how I have made this 18 of a 4-digit number just by adding 2 digits. Now 18 is made as a 4 digits number, 18.00, so that there is no change in its value, 18.00. Required number of zeros, 2 zeros are added so that it can be of 4 digits. 18 is made as a 4 digits, 18.00, and 18 is greater than 1. That's why while finding its characteristic, we have to follow this rule, n minus 1 rule. What is n there? N is a number of digits before decimal point. How many digits are there before decimal point? 2 digits, 1 and 8. Before decimal point, 2 digits are there. N is equal to 2 minus 1, and its characteristic will be 1. Now, while finding logarithmic value of 18, we have done part of that. Characteristic is found, integral part is found, that is 1. How is that done? By using rule, characteristic is equal to n minus 1. Now, to find its mantissa, what we have to make it? After finding the characteristic, first 2 non-zero digits of the given number. First 2 non-zero digits means 18 only. First 2 non-zero digits have to be located in left column. In this column, left column, first 2 non-zero digits, that is 18. Third digit, what is third digit? 0. Then the fourth digit is again 0. Then where that third digit should be located? Third digit should be located in the horizontal top row. Then to find the mantissa part of this number, of this example, 18, how we have to follow the table? First 2 non-zero digits, 18, third digit 0, 18 under 0 we have to see in the same logarithm table. In left column 18 under 0, 18 under 0, look at this, 18 under 0, that is 2553. The value in table what I am getting, that is 2553. If I go through, I am locating 2 non-zero, first 2 non-zero digits, 18 in left column, third digit 0 in horizontal top row, 18 under row. See how I am saying that? 18 under 0, 18 under O. The value given is in this table is 18 under 0 is 2553. 2553. I told you in the table the value should be taken along with the decimal point. Now what value I am getting there? 18 under 0, 18 under 0, 0.2553. Fourth digit is 0, but actually fourth digit should be seen in the mean difference column. But mean difference column is started from 1, not from 0. Then leave it. Then if fourth digit is 0, then leave it. You just concentrate on the 3 digits. First two non-zero digits in the left column, third digit in the horizontal top row, that is 18 under 0. Refer that table to find the Mantissa part of this number. 18 under 0 is 0.2553. It means its characteristic is 1 and Mantissa is 0.2553. Overall, logarithmic value of 18.00 is 1.2553. In other words, how should we understand this? Which implies if I multiply 10 these many times, how many times? 1.2553. When I multiply 10 these many times, definitely I am going to get 18. Now I think it's clear how to find the logarithmic value of a given number. With one more example, let us take a less than 1 value. For example, if we are asked to find the logarithmic value of 0.2783, this is the number of which we are asked to find the logarithm number. Now, first what we have to do? We have to find its characteristic. Then we have to find its Mantissa. Because logarithmic value of any number is consisting of two parts, characteristic part and Mantissa part. Now first find out characteristic of this. To find the characteristic, what we have need to do that? We have to check that number, whether is that greater than 1 or less than 1. 0.27 is less than 1. This is the given number of which logarithmic value is to be found. 0.27 is less than 1. 0.2783 is less than 1. If given number is less than 1, then after that number, characteristic, how should it be found? If the given number is less than 1, characteristic of such number is minus of n plus 1. Characteristic of such a number which is less than 1 is the minus of n plus 1. What is n there? N is number of zeros. N is the number of zeros after decimal point and before non-zero digit. Remember, if the given number of which logarithmic value is to be found, and if it is less than 1, then characteristic of that number can be found by following the rule minus of n plus 1. There n is number of zeros after decimal point and before non-zero digit. Here I am supposed to find the characteristic of this number. Here decimal point 0.27 by following this rule minus of n plus 1. What is n there? N is the number of digits before non-zero digit after decimal point. After this decimal point and before this non-zero digit. What is non-zero digit there? 2. In this example, after this decimal point, before this non-zero digit 2, how many zeros are there? No zeros at all. This 2 is followed immediately by this decimal point. After this decimal point, before this non-zero digit 2, there are no zeros. There are no zeros means n itself is a 0. For this example, n is equal to 0 minus of n. After decimal, before non-zero digit, number of zeros is equal to 0. N is equal to 0 plus 1, 0 plus 1, 1 with the negative sign, minus 1. Characteristic of this 0.2783 is minus 1, and I write that as a bar 1. Characteristic of this number is a minus 1 or bar 1. Now, next find out its mantissa. How should that be done? To find the mantissa, I told you already characteristic is found. Now, directly first two non-zero digits, whatever you neglect this decimal point, other things while finding the mantissa, because that is already taken into account in the form of a characteristic. Now we are finding its a mantissa. While finding the mantissa, make use of a table. First two non-zero digits. Which are the first two non-zero digits? 27. Where should those be located? In left column. In this left column table, 27. Here it is 27. You go through table, you will find 27. 27, first two non-zero digits. Third digit is 8. Where should that be done? Third digit should be seen in horizontal top row. It means 27 in the left column. First two non-zero digits. Third digit is 8. Where should it be located? It should be located in the top row. 27 under 8. 27 under 8. The value is 4440. 27 under 8. The value is 27 in this row. Under 8th column, value is 440. In the table, 4440. I told you mantissa part should be taken along with the negative sign. That is 0.4440. But here, fourth digit is also existing. What is the fourth digit? 3. Then first two non-zero digits, 27. Third digit in top row, 27 under 8. In the same row, mean difference column. If there is a fourth digit, look at that mean difference column. 27 in the same row, under mean difference column 3. Under 3. Mean difference 3. 27 left column. Third digit in top row, 27 under 8. Mean difference 3. 27 under 8, when it is seen, I have got a 0.440. To this, add mean difference value also. 27 under 3 mean difference value there in this column. 27 under 3, the mean difference value is 5. When it is seen, 27 under 8, the value is 4440. Fourth digit 3 when you see in the table, that value is 5. Now add that mean difference value with this table value. On adding, this will be 0.445. Now mantissa part of this number 0.2783 is 0.4445. This is the logarithmic value. Logarithmic value of what? Logarithmic value of 0.2783. What is that? Bar 1.4445. In other words, how should that be understood? When I multiply 10 these many times, how many times? 10 to the power of 1 bar 0.4445. When I multiply 10 these many times, I can get this number. Which number? 0.2783. or it can be written like this: 1 divided by 10. Bar 1 is written as a 1 divided by 10 because this is a minus 1. 10 to the power of minus 1 means 1 by 10. 1 by 10 is a 0.1. On raising remaining Mantissa part, if you multiply 10 these many times, you will get this number. This is how we can express that any given number in terms of a power of 10. I think you followed this so far to how to find the logarithmic value of a given number. Logarithmic value of a given number is consisting of two parts, characteristic and Mantissa. Characteristic can be found by the method of inspection by following the two rules: ch is equal to n minus 1 and ch is equal to minus of n plus 1. Mantissa part can be found by using logarithmic table or a scientific data book. That too by making a given number of 4 digits. First two non-zero digits should be located in the left column. Third digit should be located or seen in the horizontal top row. Fourth digit should be seen in a mean difference column. That's why even if you get the table, scientific data book, mention that in the left column. How I did it here. First two non-zero digits in left column. Third digit in horizontal top row. Under here it is mean difference. Fourth digit in mean difference column. Fourth digit. If the given number is of more than 4 digits, I told you, then that given number, if it is of more than 4 digits, should be made of only 4 digits by rounding that 5th digit. By rounding off of a 5th digit. If it's short small, if the given number is having less than 4 digits, then also you can make that given number as of 4 digits just by adding some more required number of zeros. If the given number is of only 2 digits, you can add 2 more digits in front of that number so that it can be of 4 digits. And the log has its own limitation. Up to 4th digit number only we can find the logarithmic value. That's why on seeing its limitation, the given number of which logarithmic value should be found, that should be made of 4 digits, either by rounding off of a 5th digit or a 6th digit. If it is number is more than, it is having more than 4 digits. If it is a shorting form, then you can add some required number of zeros. It can be made of 4 digits. In next session we will see how to operate the numbers by using the laws of logarithm.